What is thread? Thread is a Java class belongs to Java Lang package. Java provides threads class to achieve multi-threading programming. Thread class provides constructors and methods to create and perform operations on the thread. In its scenes, thread class extends object class and implement runnable interface. The Java virtual machine allows an application to have multiple threads of execution running concurrently. Hence, thread class, which belongs to Java Lang package, like any other object in Java, it has variables and methods and lives on the heap. On the other hand, its execution is an individual process, also sometimes called as lightweight, that has its own code stack. The main method in Java program runs as the first thread in the application, and when it is stack traced, it is also seen on the execution logs. But when an if thread is created, an if stack creates, and methods called from that thread run in a call stack that is separate from the main method call stack. Since threads are independent, if an exception occurs in one thread, it doesn't affect the other threads. Threads are used to create simulations of taking advantage of multiple CPU cores in a machine. A thread helps facilitate multitasking within a program. It utilizes CPU effectively and helps improve the performance of the application. Java enables the user to use multiple threads at a time. It can run in parallel with other programs without any interruptions. This helps reducing the time for the process. A thread is sometimes called as lightweight subprocess. And also can be referred as the smallest part of the process which can be executed concurrently with other threads. A thread is executed inside the process. There is a context switching between the threads. There can be multiple processes inside the OS, and one process can have multiple threads. It is a separate path of execution because each thread runs in a different stack frame. A process may contain multiple threads. Threads share the process resources, but still they execute independently. It is related to the amount of the context associated with the thread, and consequently the amount of time it takes to perform a context switch. Heavyweight threads, like kernel or US level threads, has lots of context, like hardware register, kernel stacks, etc. So it takes a lot of time to switch between threads. Heavyweight threads may also have restrictions on them. For example, on some kernel threads cannot be preempted, which means they can't forcibly to be switched out until they give up control. Lightweight threads, on the other hand, usually user-created threads, much less context. They can essentially share the same hardware context. They only need to store the context of the user stack. Hence, the time taking to switch lightweight threads is much shorter. Any thread you create as a programmer in user space will be lightweight in comparison to the kernel space threads. There is no formal definition of heavyweight and lightweight threads. This is just more of a comparison between the threads with more context and the threads with less context. So also because every OS has its own different implementation of threads, the lines between heavy and the light threads are not necessarily clearly defined. In some programming languages and frameworks, when you create a thread, you might not even getting a full thread. You might just be getting some abstractions that hide the real number of threads underneath. What are the major differences between thread and process? A program in execution is often referred as a process, whereas a thread is a subset of the process. Processes require more system resources, whereas threads are lightweight execution units. A process has its own address space, whereas thread shares the address of the created process. A process can communicate by using inter-process communication, whereas a thread can communicate by inter-thread communication. Inter-process communication is slower and expensive than inter-thread communication, whereas inter-thread communication is faster and cheaper. The creation of the nib process requires duplication of the parent process, whereas nib thread is easily created. A process does not have to control over the siblings process, whereas threads have control over the other threads of the same process. Let's get into the detail of the description. Regarding the first item, processes are independent applications, whereas threads are the subset of the process. From the operations system point of view, a process is an independent piece of software that runs on its own virtual memory space. A process is a self-contained execution environment, and it can be seen as a program or application, whereas thread is a only single task of execution within the process. Java runtime environment runs as a single process which contains different classes and programs as processes. A process has an execution environment provided by the operating system that has its own set of private resources like memory, open files, etc. In Java, threads live in the JVM and can be created and stopped up by the Java application dynamically at runtime. Processes are heavyweight tasks running in their own allocated memory space. Threads are lightweight, spawned with the process, and share its memory. One process can have multiple threads. Thread requires fewer resources to create and exist in the process. Thread shares the process resources. The ability to share resources between threads makes the threads more suitable when performance is a significant requirement. As a second difference, processes require more system resources, whereas threads are lightweight execution units. Threads have less overhead compared to process in terms of metadata, context switch, and CPU and memory requirements. A process has its own address space, whereas thread shares the address of the created process. Processes has different address space in memory, which means two processes run on different memory space, while threads contain a shared address space. Threads have direct access to the data segment of its process. As a detailed and important information shared means only heap area. Additionally, every thread has its own stack in the memory. Inter-process communication is slower and expensive than inter-thread communication, whereas inter-thread communication is faster and cheaper. A thread is usually referred as lightweight process. In regards to communication, inter-process communication is difficult, while threads can communicate easily using the Java methods of wait, notify, and notify all. Context switching much faster than the threads comparing the process communication. Inter-process communication is defined by operating system as a kind of intermediate API. The creation of a new process requires duplication of the parent process, whereas a new thread is easily created. A new thread can be created, but the creation of a new process requires duplication of the parent process. A process do not have control over the sibling process, whereas threads have control over the other threads of the same process. Processes are independent, hence any change can be made to process doesn't affect the child processes. On the contrary, if changes made are in a thread like cancellation, priority change, switching to another state may affect the behavior of the other threads, there are possibilities that other threads may be affected. What properties does each Java thread have? Every thread has properties as having an identifier of type long that is unique within the JVM, a name with a type of string, a priority with type of int, a state with type of enum Java-lang thread state, and a thread group which describes thread belongs to. What are the available methods in a thread class? There are lots of methods as you can see on the table, with some of them are depreciated along with the newer Java updates. Some of the important methods are start method, it is used to start the execution of the thread. Join method, it waits for the thread to die. Get priority returns the priority of the thread. Set priority changes the priority of the thread. Get state is used to return the state of the thread. Is daemon test if the thread is daemon thread. Get state is used to return the state of the thread. Notify is used to give notification for only one thread which is waiting for a particular object. Notify all is used to give the notification to all waiting threads of a particular object.